Good day all, this is Professor Friday coming at you one more time. Today we are going to be solving a trigonometric equation. Today we've got solve 1 minus 4 times the cosine squared of theta is equal to 0. And we're going to solve this on the interval 0 to 2 pi, where we're allowed to include 0 but not 2 pi. As we're about to find out, we don't really need either one of them. So, as I was telling my students in class, the first big goal is to obtain the following form. Since we've got cosines in this problem, we want to see if we can get this down to cosine of theta is equal to just a single ratio. Now, we've got a cosine squared in here, which means eventually we're going to come up with two different values for the cosine. That is kind of the nature of having something to the second power. If it was to the third power, we'd probably wind up with 3. If it was to the fourth power, we'd get 4, and so forth and so on. So, for this one, we're going to have to reach back to our algebra skills and see if we can start by solving for the cosine squared. Solve for me. So algebraically, let's subtract 1 from both sides. Get negative 4. Cosine squared theta is equal to negative 1. And then divide both sides by negative 4. Now, 1 over 4 can't really be reduced, but you can cancel out the negatives. So we'll do that. So we get cosine squared of theta is equal to 1/4. We're trying to get this down to cosine of theta is equal to something, so we need to get rid of that second power. To get rid of that second power, we can take a square root of both sides. Apply square root. Now when we apply a square root to both sides, it's going to cancel out the square on the left-hand side, and we'll get plus or minus the square root of 1/4. Anytime we take a square root of both sides of an equation, generally you're going to see a plus or minus sign. We've talked about that before when we were solving for values of a, b, and r on the circles. So this takes us down to two possibilities. Cosine of theta is equal to 1/2, or cosine of theta is equal to negative 1/2. So, real quick here. Okay, close enough. On our unit circle, the cosine of theta is equal to 1/2 at two different points. There's a point in quadrant 1 and a point in quadrant 2, both of which have an x-coordinate of 1/2. We don't really care what the y-coordinate is. If you take a look at the unit circle, you should be able to figure out what those two values are. The one in quadrant 1 is going to be theta equals the arc cosine of 1/2, which is equal to pi over 3. The one down in quadrant 4, by symmetry, would be 2 pi minus this value, which would take us down to 5 pi over 3. Now for our other guy, the cosine of theta is equal to negative 1/2, we're actually going to use a little bit of symmetry here. There are two different values, one in quadrant 2 and one in quadrant 3, where the value of the cosine is negative 1/2. And again, we don't really care what the one for y is. Now the good news is that these four angles are all reference angles of each other, so that's good news. Over in quadrant 2, we could say that theta is equal to the arc cosine of negative 1/2. That's generally how we get our first answer. That angle is equal to 2 pi over 3. And then down in quadrant 3, as we did before, we do 2 pi minus this value. And we would get an answer of 4 pi over 3. So that's 4 different angles where this works out. Let me write all 4 of these together as a solution set. Or not a solution set, just theta equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Final answer for this one. Alright, hope you found this informative. I will see you again sometime soon.